Hey y'all, I wanted to start our next unit of notes here. So we're going to start jumping into rectangles and squares to begin with. Our next unit, we're going to be talking about area, surface area, and volume. But we have to understand the general practice of what is area first before we can really get into all the fun stuff. So first, I wanted to start with rectangles because rectangles have two different dimensions. Their dimensions, we have length and then we have width. A lot of times you use the cursive L or the cursive W to work on either of those. And then there is this formula that we always use for rectangles. Area is equal to length times width. Now, you'll recognize this formula come up a bunch of times as we talk about different shapes, just in different variations. The rectangle is kind of like the base of all of these different shapes, and then they all kind of form from there. So let's look at an example. We're going to do two different ones here for rectangles. So we are going to find the area of the rectangle given. So here's my rectangle. I'll draw it out kind of crudely here. So I like Notability. Makes it all nice for me. So this side is 6 inches. This one's 7 inches. Not really drawn to scale. But to find area, we're simply going to take the length and multiply it by the width. Now, length and width are kind of interchangeable at this point. Like we could call this side L or this side W or vice versa. It doesn't really matter as long as you're using the correct formula. So if length is equal, or area is equal to length times width, my area is going to be 6 times 7. So my area is equal to 42. Now that means that the area is 42 inches squared. Because when we're talking about area, it's whatever the unit is squared. When we get into volume, it'll be cubed. But for now, our area is going to be the units squared. So for this shape, our area is 42 inches squared. Now I'm going to kind of separate this down the middle here because I'm going to have another example kind of similar. We are going to find the length in this shape of the rectangle given the width is 12 feet and the area is 78 feet squared. All right, so these problems, it might sometimes be, that didn't draw my shape. It might be easier sometimes to draw it out and then see what you're working with. So I know that my width is going to be 12 feet. And my area as a whole is 78 feet squared, but I don't know what the length is. Now, we're still going to use that same formula. Area is equal to length times width. But instead of finding the area, I already know it's 78. I don't know what my length is, but I know that my width is 12. So then I'm going to solve for length. I'm going to divide by 12. Divide by 12. And I get 6.5 is equal to L. So that means the length is 6.5 feet. Pretty straightforward. The general idea of these two examples was, can you apply the formula given, area equals length times width, and then use what you're given in the problem to solve from there. Now, I'm going to kind of draw a little divider here for the second half of my page, and then we're going to talk about squares. So, squares. if you remember from our quadrilateral unit, squares are like kind of the like cousin of rectangles. They're just a little bit fancier. So squares also have two dimensions. But they are the same. What that means is that your length is actually equal to your width in terms of a square. So we're going to represent that instead as the side with s. So we're going to use variable s here. So a square could look like this. That looks more like a rectangle, but I'll make that look like a square. So all of these sides are congruent, and I'm going to call one of the sides s. Now, if it's similar to a rectangle, in a rectangle you find area by taking the length times the width, here you would take the side times the side, or our area is equal to side squared. So you're just going to take one of the sides and square that number to find the area. And I'm going to box this here because that's a formula. And then I'm going to make a little note over here. There will be times when you must use this formula. And I'll show you an example of one where you're going to have to use that formula of side squared rather than length times width. So let's look at a few examples here. And hopefully you got some room down at the bottom of your page. So we're going to find the area. Of the square. So here's my square. 1 centimeter is its side. I know it's a square because all of my sides are congruent to each other. So if my area is equal to side squared, my area is equal to 1 squared. So my area is equal to 1 centimeter squared. Now, this seems pretty silly that your side length is 1, your area is also 1, but in terms of the units, your side length is 1 centimeter, your area is 1 centimeter squared. And actually, this turns out to be the definition of a square unit. So this is a square unit. 1 centimeter by 1 centimeter makes 1 centimeter squared. I'm going to put another divide line here for another example. And this is one where you're actually going to have to use the formula. So find the length of each side of a square with area 288 inches squared. So now we're going to find the length of the sides rather than finding the area here. I'm going to draw this picture. I'm doing dark green. So here's my square. I know that all of my sides are congruent here, and my area is 288 inches squared, but I'm looking for a specific side length. So how we're going to do this is we're still using the same formula. Area is equal to side squared, but instead of our side, I know that my area is 288. And then to get rid of that squared part, because I just want my variable by itself, I have to take the square root of 288. So remember when we're doing square roots, we got to break this apart a little bit. So if I do it by 2, then that's 144, and then 144, that's a perfect square of 12 and 12, so that means that 12 comes out, 2 remains. Remember, back to your simplifying square roots. So this turns out to be 12 square root 2 is equal to our side length. So that means that the side length is exactly 12 root 2 inches. Oop! I threw up to the top. Inches, I had to fit that in there. Or about 16.7997 inches, actually. So there's an exact measurement, which you would use the square root here. So my exact measurement is this, the 12 root 2 inches. And then my approximate or my about measurement is this 16.97. So it depends. If it says what is the exact measurement of the side or what is the approximate measure of the side, you could use either one. So that's just our intro lesson to area. This was just talking about rectangles and squares. We'll be getting more into different shapes as this unit builds, but copy down these notes into your notebook, and then I will see you in class.